My name is Rich Petersen. I'm Director of Product Management for the Software Solutions at SanDisk, which is now part of Western Digital. With me is Serge Shats, who is our Engineering Fellow and the Chief Architect of our FlashSoft software. The topic that we want to move on to now is something that we call the Flash Virtualization System. Now, the Flash Virtualization System basically answers a question that we get from a lot of customers, which is, I have a lot of host servers. I wish to provide caching using your software, but I don't like the idea of powering down those servers and installing a solid-state device inside each of them. Is there a way for me to use an external cache resource, an external solid-state resource, as the caching mechanism for my ESX environment? And in response to that, what we did was we took a look into one of the great technologies that we took on in the Fusion IO acquisitions, which was the Ion Accelerator. If you're not familiar with the Ion Accelerator addressed the simple problem of how do I take the IO memory devices that I like so much and concatenate them, pool them, and make them a shareable resource within my cluster. So it's a great software solution for enabling IO memory devices, and now as we're a part of Western Digital, we're doing this with HGST, NVMe PCIe devices as well, but the ability to provide basically a server full of flash and make that a resource that can be used within a cluster. Now, the standard use case for this kind of thing would be database acceleration, but we also took a look at, couldn't we make this the cache resource within the context of a VMware cluster? And that's where the Flash Virtualization System comes from. So, Serge, I'd like to turn it back over to you. Okay? Because when we move from the idea of caching with an internal SSD inside each host server to the idea of caching across a cluster of host servers that are sharing a pool of flash in a single server, there are some interesting things that we come up with in terms of benefits and possibilities for the future. So, Serge, can I turn that back over to you?
Sure. Yeah. Okay. As a matter of fact, you can look at this external SSD as a kind of software managed data tiering. We have hot layer in this virtualization system, external SSD, and we have whatever underlying storage that it is basically cold data, if you like. By the way, it is important that we support, as a FlashSoft, we support all type of shared storage, and not only shared storage, for example, vSAN. We'll talk about, by the way, FlashSoft and vSAN at the second part of our conversation. Again, it is important that it could be cheap or expensive external storage. It could be NFS, SAN VMFS with MFS on the top. It could be vVol, whatever. So we accelerate. But hard data we automatically recognize and keep in external SSD. As well as internal SSD, but external SSD has, as Rich mentioned, several very important advantages. Let me maybe elaborate a little bit what you said about just what is easy, internal SSD or external SSD. You can argue, you can say, okay, there is SFF SSD. You should not open box. You can just plug SSD, NVMe, for example, and you don't need to at least open the box. Maybe sometime you have to reboot machine, but usually you don't. But there is a couple things. First of all, if it is a brownfield, so it's an existing data center, existing set of servers, you may not be able to insert this SSD internally like this hot pluggable SSD. In this case, you have to open the box and install PCIe, which is PCIe device, which is painful. If it is external SSD, you don't need to open the box. It's just a rack rack, pluggable, whatever.
Top of rack system.
Top of the rack system, thank you.
Yeah.
Top of the rack system, and it is easier. But there are also some definitely advantages, just technological advantages of using external SSD. You know what? I really like questions. If you have questions, please ask the questions. Especially when I start telling you about advantages of external SSD. First of all, when in a previous diagram that we showed, when we have internal SSD and we have write-back caching, we have to replicate to have at least one extra copy of data that we put into the cache to have it in a second host. This is our way to currently to deliver high availability. And as a matter of fact, replication, do we want it or not, is between 100 and 200 microseconds, round trip. And if we have device with 30, 40 microseconds access time, we kill latency. For writes, we just literally kill latency. As you can notice, external SSD does not require replication.
But it does have latency, a lot of latency.
Really, if it is NVMe over Fabric, what's the latency? 8 microseconds? If it is RDMA. We're not talking about traditional fiber. Thank you. It's first question.
Yeah, that's where I'm going.
First remark. Thank you.
Hey, you're geeking out about storage, so I'm right there with you. I'll talk storage with you all day long.
Actually, we're talking RDMA, Rocky, and I believe VMware will have very soon support for RDMA, according to our information, kind of. And VMware Fabric is coming, and a lot of this low latency fabrics is coming. It is very natural, and as NVMe actually won in the market, NVMe over Fabric, sooner or later may win this the market. So it will not kill the latency. So number one is good for performance because we do not need to replicate for write back. The second reason is the following. Of course, this device must be high available, one way or another. We can develop high availability in the software, or like Ion. Ion may have some, basically it's two Linux boxes with PCIe and replication, DRBD-based replication for high availability. It could be replication inside this box, or as I said, if we have two boxes and in VMware Fabric, probably first of all you will see just JBOF here and here, and we will deliver high availability from our software. It is very good for vMotion. If machine move from one host to another, data kind of, because it is sitting in external SSD, follows, the data follows virtual machine because it is here. It is fully available for all hosts in the cluster. You see what I mean, right? So it's very good for vMotion. It's good for failover because there is no rewarming cache. Data is immediately available as well as for vMotion. One more interesting implication for this external SSD is actually acceleration of hyperconverged storage. We will talk again later in details about this, but if for hyperconverged system, we actually at this moment we cannot use internally attached SSD in write-back cache mode. Why we cannot? For high availability we have to replicate, right? And hyperconverged system replicate for high availability. So we have double replication, which is horrible, and nobody would. It looks terrible. It doesn't work from technology standpoint of view. But external SSD, because we do not need to replicate, it may be used for acceleration for write-back in write-back caching as well. So bottom line, there are many marketing and technological advantages of using external SSD, and Western Digital and SanDisk. Western Digital has additional products in this area. You will see, it's not in a GA, so probably I don't know.
No, we shouldn't talk about that.
We shouldn't. But anyway, no, if you say this, it means that I can talk. If you say this, I can.
Okay, this is a no.
Okay, sorry. Okay. So
It's going to be good.
But it's important to note that what you're talking about when you say external SSD is not just an all-flash array.
No.
It's not some fiber channel or iSCSI all-flash array. It's a low latency fabric solution, top of rack flash kind of solution.
Thank you again for your remark, because it's one more topic related to this. This is more for discussion than that's my personal view on that, and I'll be happy to discuss it with you.
It is kind of like a cache SAN in a way, because one of the advantages of having a central SAN would be for hot failover.
It's not even SAN. It's not even SAN.
Correct.
It is just.
It's shared storage.
It's shared storage which is attached over a fabric.
Yes, over the
So
fabric.
we can. It's a fan.
SAF? No. Storage area fabric?
A SAF. Yeah.
Well, no, but what you're describing, everything you're saying is exactly the justification for shared storage generally.
Yeah.
So the reason people have SAN and NAS is exactly what you're saying, except you're using it for cache, for caching, whereas previously none of these protocols were fast enough or capable for caching.
Here we are.
So you're basically adding another type of storage that's shared.
Yes.
But the point to emphasize, of course, if I can
Go
jump
ahead.
in,
Yes, of course.
is that what is cached and how it is cached is entirely defined in software in the hypervisor. So we're completely outside of any hardware dependency whatsoever. An obvious point, I know, but it's one where people frequently say, well, how is this any better than a hybrid, flash plus disk-based system? And the answer is, it's just got so much more granularity and intelligence and insight into what should be accelerated and what doesn't need acceleration, what is falling below an SLA, whereas what is over-provisioned with flash. And this is what's we didn't talk about SLAs yet.
Yeah, we'll talk. Yes.
I'll leave that to you. I'll leave that to you.
Thank you.
Yeah.
It's a CAN, really. I mean, it's not a storage area network. It's a cache area network.
Yeah.
So I like CAN. I'm going to go with that.
So, but
I'd like to continue. I'm sorry for interrupting. I'd like
continue
to.
So this is it
to answering
sounds
this
very
question.
similar to Pernix data or Infinio in terms of it's a caching thing. And one of the benefits of Pernix and I believe Infinio as well is that they have a distributed caching type thing. It uses in-host memory
Yes.
to do the acceleration, whereas this is using SSD, which is bigger and cheaper.
Yeah, personally, I'm not a fan of in-memory caching because latency will kill performance. That's many reasons.
And memory is fairly expensive.
Memory is very expensive,
Correct,
but I would like to continue what actually you mentioned, because you mentioned several times SAN and NAS. And that's what I'd like to just to put for discussion, for the sake of discussion. If you take a traditional, I would say now traditional all-flash array, pure or extreme I/O, there is a substantial difference between shared storage as a cache and shared storage as a primary storage. Shared storage as a storage for cache is very different than storage as a primary storage, even if it is all-flash array. The difference is everywhere. Set of features. Do we need snapshot? Of course not. Do we need replication for DR in the caching? No, not at all. Do we need any standard protocol like SAN and NAS, as you mentioned, Steve mentioned? No, we don't.
Just one point on that about distributing the cache for DR. You say that we don't need it. Yeah, we don't, but however, so replication, sorry.
Yes.
So we sort of do, because if I fail over, my cache is gone, everything's slower now.
That's right.
And I've got to warm the cache up again.
That's right. Yeah, you do need system level high availability. So if we're going to use this system in write back mode, we do have to have redundant systems.
Yeah.
For exactly the failover that you're describing.
Yeah.
But that's so that in a write through mode, the current product that we have available today, you can run with a single box. when we move to write-back caching on this system, it will be a two-box system.
Yeah. And by the way, back to what you mentioned, there is a different scenarios in failover and for vMotion. Failover is a pretty rare situation because it's a host is down. It's kind of rare. vMotion is much more frequently happened situation. So even if you have internally SSD and machine move from here to here, you can retrieve data from this cache and reworm cache faster. For failover, there is no way of doing this, and you have to use if machine move over there. Yes, you can use second host for data, but it will be only write data, not read data, and it looks a little bit ugly. If you have external cache situation, is very different. Data is here all the time, whatever, failover or vMotion. Data is here, it is available. It is attached to the virtual disk and sitting here. And this box is attached to all hosts. So it's a benefit. So I'm sorry, back to what Steve mentioned. And I believe it is very important. External SSD for caching, could you please somebody say no and we'll start discussion.
That's the stupidest idea I've ever heard.
Thank you. Finally.
I can't believe you asked me to say that. Okay.
Yes.
I'll say it for you. I'll go.
No, I like it. Yes,
Okay.
yes. Could you please tell me why it's a stupid idea?
Well, because it's not in the box, and it's going to be slow, and it's going to be unreliable. And
Yes,
what happens if
yes,
the network
totally
breaks?
agree. Totally agree. I'll continue.
There we go. Okay. Well, we've been saying this about storage over the network
Yes.
forever. And so it's the same
Yeah.
arguments.
Finally, it's getting reality because NVMe over Fabric, because of RDMA, and this storage. What do we need from this storage as a cache, as a hot layer? I would say, because I started with a statement that actually it is a tiering, storage tiering. We need a latency and capacity, throughput less. But latency, absolutely important. And it requires different protocols, which is RDMA, NVMe over Fabric, but some fabrics. It should be different design internally to deliver really very low latency. And if you remember my first statement, it is very different. Requirements are very different than requirements for all-flash array as a primary storage. One more. Thank you, Rich. Remind to me. One more advantage of external SSD is basically providing SLA. What do you mean by that on a storage level? Typically, SLA is developed by throttling IOs. If you have high priority virtual machine, you provide high number of IOs for this virtual machine. Is it interesting for you what I'm telling about? Yes? It is okay, right? Mm-hmm. Okay, just let me know. We'll go deeper or whatever. But there is another way of implementing SLA. And this is basically amount of space in a hot layer that you can allocate for virtual machine with high priority or with high demand in I/O. Shared storage allow you to much easier to redistribute space, hot data layer space between virtual machines. If SSD is internally attached, it is very hard to say, okay, I have virtual machine here, but data is here. It doesn't work because of high latency when we access this. That's why when SSD is internally attached, we just concentrate, we move data as close as possible to this virtual machine. It is sitting on the same SSD as this host where machine is running. If it is external SSD, we are free to reallocate space between virtual machines, actually virtual disks.
Are you talking about running virtual machines remote from their storage on different servers from the storage?
Yes, it is.
So you could have
ESX cluster running virtual machine, the hot data is there, and the space that we allocate for each virtual machine, it is much easier to redistribute according to priority and demand in I/O. So this is one more reason for using external SSD.
Yeah, and Serge, if I can interrupt, this is why we call it flash virtualization. Because essentially the flash is no longer connected to the server itself. So if I have...
Well, no, essentially the flash is connected to every server.
Better.
It's not that it's not connected, it's that it is connected, and that's better.
Right, it's entirely fungible based on the I/O requirements.
Okay, so we think that, especially because of fabrics that is just booming now, we believe that this is a future for hot layer implementation, and we're actively working in this direction to deliver this in overlap with what we're doing with our current development, which is based on internal SSD, but we'll be very soon with external SSD.
Yep. Well, we actually are demonstrating it today in write-through mode with the single box, and soon we'll be demonstrating it with write-through mode, write-back mode, with a dual flash server configuration. So that's kind of the direction that we're taking this concept of flash virtualization. It's a new kind of system. As we said, it's not a host, it's not storage, it's something in the middle. CAN is maybe the working title.
Yes, we can.
The working title for this project. But
VCAN?
Taken.
But
Where's my data? It's in the can.
just your hot data.
Yep. Yeah, exactly. It's like a can of baked beans or something.
All right. But that's a quick summary of the topics that we wanted to walk you through today. Basically, that after years of collaborative development with VMware, FlashSoft 4 is the VIO-based caching software that's available for use with internally attached SSDs, with the external flash server based on our Ion accelerator. The flash virtualization system leverages FlashSoft in very much the same way. Literally, the interface to the two products it's identical. There's just a little checkbox that says my flash is outside my server. You check that, point it to the flash server, and you're off to the races. That's a quick overview of what we're talking about today with the folks on the floor at VMworld, and a little bit about where we're going in the future with write-back caching with the flash virtualization system.
And this is just available for VMware?
I'm sorry?
This is just for VMware.
This right now is for VMware. We still do have, of course, our Windows and Linux caching solutions, which will provide write-back caching in an unclustered environment, and we have some use cases for that. If you're running Hyper-V with cluster shared volumes, the write-through cache will allow you to accelerate a Hyper-V environment at the Windows Server level, below Hyper-V.
But I think it's a politically incorrect question on VMworld, okay?
I didn't say Microsoft, he did.
Yeah.
Actually, I'm Windows. I learned with, I was born inside Windows.
Really?
Okay.
We developed a lot.
He doesn't look a lot like Clippy, but you know.
Well. All right. This is very interesting. I mean, you know, as you said, these things are coming. These top-of-rack flash systems and NVMe over Fabric coming from multiple companies and multiple startups. And the question is, how do we use these things? So we're getting top-of-rack flash with Fabric connections and low latency connections. And the question really has become, you know, what are we going to do with this top-of-rack flash? And until now, until this idea, the answer has always been, well, you're going to run something really fast on it. Yeah. You know, oh, I want my virtual machine to be super fast, so I'm going to run it on this, and won't that be great? But that's not really a great end of discussion use for these products. I mean, it's nice that you're coming up with another use for...
Well, it's host-based data tiering.
As an employee of Western Digital, I can say I have nothing against hard disk drives for large capacity storage.
Yeah.